steering control, right? Steering control also I told you. When
Your
assisted
assisted
steering,
steering,
we
we
talked
talked
about
about no, when
press
you
this
press
one
this one
automatically.
automatically, it will release. Sharp turn. If you turn your steering control, correct? So manually.
Sir, I have a question, sir.
Yeah, yes, please.
Sir, you said that means driver when he is going for adaptive cruise control, he will be setting for a particular speed, and
Okay.
then when something comes in front of it, then it will change the desired speed.
Yeah,
So
correct.
once the desired speed is changed, sir, like how it will further means whether it will take a turn or something, or it will go with the same speed, and how it will again
When
get to the
you are not seen. And that's what it's a cruise control you have to see because we are in the second slide only. You are wait. And so what are other things? Okay. So cruise control will be really see again you are included when speed see the last line. Cruise control will be released automatically whenever driver presses clutch pedal. Correct? It is not automatic this one, manual this one gear system. Correct? So you know that when you are tops this one fifth gear, vehicle can go to something around 40 kilometer, 80 kilometer easily. No, top gear itself. You need not change gear. Even up to 100 kilometer it can go. In top gear it can go. Correct? But when the speed comes only you change. That means if you are pressing clutch means you set the speed as 60 kilometer. That means if you're a top gear, fifth gear, for example, Honda City. Correct? It is going to you set 60 kilometer. There's no need to change the gear. Correct? Speed can vary also it can. You can set any speed within say 40 to say 80 kilometer in the top gear. Fifth gear vehicle can go. You set 60. Cruise control. You are going. Now, if I want suddenly something comes, you want to take control. Once you press the clutch control, right? That means you wanted to release the cruise control. You are telling the cruise controller, I am going to take control, manual control. You release the control. If you press the clutch pedal or brake pedal, or if you start steering, yeah, sharp turn is coming. Fantastic. That's what I'm saying. Because we had so vehicle is going. So you set cruise control 60 kilometer speed, but you know the curve is coming. Cruise control will not reduce the speed. Be careful. Suppose you are having Honda City, you are set to cruise control 80 kilometer speed. Correct? Short turn is coming. Cruise controller will not reduce 80 kilometer, 40 kilometer and all. It will go, you definitely will go out of the vehicle. So immediately you have to take control. When you see turning all these things, correct? If they can just cruise control, even adaptive cruise control, if there's no vehicle in front, correct? So it will not reduce the speed. It will try to maintain the same 80. Whenever the curve comes, what you do? You start steering. Once you start steering, immediately cruise control knows that this is a manual control, it will come back. It will give the control to the human driver. So this is your responsibility to the see. This is only assistance system. Please note it's not autonomous vehicle. The cruise control and adaptive cruise control are driver assistance system. The driver job to drive the vehicle safely. It assists us. ABS, steering control, and cruise control to assist driver. Some amount of load can be reduced so that you can relax. But still, you are the responsible. So in the turning, that's why I said if you clutch pedal means you want to reduce the speed, change the gear. Correct? Otherwise, you press a brake, you want to stop it. If any of the signal comes to the all the signal, clutch pedal, there will be a switch. Brake pedal, there will be a switch. There's a steering sensor, angle sensor. All these things will come to cruise controller also. Not only going to steering control, it also the signal will come to cruise control also. It will automatically release. Okay, so this is what this is. Please take the please an exam means I expect these diagrams. Write about cruise control adaptive means you have to draw the block diagram. I'm not asking you to take a scale and this one like a drawing class. Manual sketching you have to do. Correct? So please see that this is old generation car. Cruise control was installed in the American cars 1950s itself. That time fuel injection was not there. Only carburetor. The carburetor throttle valve was generally controlled by manual. So this is the throttle cable. You can see that. You press the throttle pedal, the long cable or link is there. That will be controlled by additionally by a vacuum actuator that time. They did not use that, but in some cars they use electric motor also. electric motor or vacuum actuator, which will pull the cable. Because the mechanical cable will be pulled by driver, press and release, or by this vacuum actuator electric motor. This electric motor will be controlled by the cruise control computer. There is not an ECU, electronic control unit. What are the inputs to it? What are the input to it? Steering wheel sensor. Correct? That's what I told you. If you are steering, that means you want to take a turn. That means the speed at which the vehicle is maintaining speed may not be maybe too high. 60, 70, if you turn it, your vehicle will topple. So automatic cruise control will release. If you turn your steering wheel, immediately cruise control beyond certain limit. Correct? Minorly, if you see small, it may not release. If you turn, say 5 degree, 10 degrees, something like that, immediately it will release. Then vehicle speed sensor. Again, we told you the cruise control will work only above a certain speed. If vehicle speed is reduced considerably, right, then the vehicle automatically will be released. Then clutch pedal, that means you want to change the this one gear in a manual. So top gear you want to do, the vehicle is going to 40 something, you want to come to manual mode. Or you press the brake pedal. If you do any of these, cruise control will be deactivated. If the cruise control receive any of the signal, cruise control will deactivate, it will go to manual control. Otherwise, it will generate control signal. Correct? Cruise control will generate a control signal that will go and control the actuator. Correct? Vacuum actuator or electric motor. In case of carburetor, electric motor, which is going to physically pull the cables like a human driver. Correct? To accelerate, decelerate. But if it is a fuel injection system, cruise control will give a signal to the ECU, fuel injection ECU. This is fuel injection system. It will give a signal, and the fuel injection system in turn will control engine, so vehicle speed is controlled. Right? That's how it works. Take the functional block diagram, because you are supposed to draw all this in the exam. Right? Because within another 5 to 8 days you have exam.
Professor, again, like my question again, I'm trying to understand one thing is that you have told in the doing this thing like the cruise control which is installed in Honda City or what I mean to say is like other Hyundai car that you have told. They are telling that minimum speed which is required to be maintained for activating the cruise control is 40 or maybe 50 or 30, something like that. What are challenges cruise control is facing so that it is not getting activated below 30 or 40 kilometers? What are the challenges that they follow? Why the limitation of minimum speed?
That's what they say, if in highway, correct, bumper to bumper traffic, what is the inter-vehicle space you will maintain? Well, see, bumper too heavy traffic in highway itself. You will see many times cars will be going 40 km, 30 km speed only. Correct? So the vehicle to vehicle distance will be less. Suddenly somebody can apply brake. Cruise control doesn't have braking. It will try to maintain speed, so your vehicle will go and hit.
Okay,
See,
got it, sir.
Vehicle speed below 40 means you know that you are in high traffic condition highway or in city.
So it's more of a safety.
It is for safety only. It is safety because cruise control will not apply brake.
Not for a technical.
Not technical. Not technical.
I got the point. Thank you.
Okay. What is advantage of cruise control? Maintains a safe distance between the vehicle as long as vehicle in front of maintains same speed. Safe distance is possible only if the vehicle also maintains same speed. I am talking cruise control, not adaptive cruise control. Correct? In cruise control maintains irrespective of road gradient, vehicle in front even stops. You apply brake, 0 speed, your vehicle will go and hit it. At a 60 km speed, it will go and hit if you don't start manual control. Okay? Main other advantage, fuel efficient. Correct? In a highway, if you maintain 60 km, they call cruising speed. Correct? Mid throttle position. I told you maximum fuel efficiency, minimum emission. Correct? COHC emissions are minimum, mid throttle condition engine operates. Correct? Fuel efficient, maximum fuel efficiency when you operate a vehicle at mid throttle condition. Aerodynamic drag is less. If you go to 100 km, 120, aerodynamic, V square. Correct? Velocity square. If you higher the speed, more the drag. Correct? You lose lot of fuel. Correct? That's why you won't get mileage when you go to high speed. If you want to 80, 90, 100, 120, if you go, you won't get mileage. Apart from the road friction and the aerodynamic drag increases V square, velocity square. Then reduce the risk of rear end collision. So you maintain constant speed. These are the main advantages. What is drawback? Collision can happen in situations like vehicle influence suddenly decelerates or applies brake. Cruise control doesn't know whether vehicle in front apply, but nothing is knows. It try to maintain the speed. As there is no way to find obstacle in front because there's no such system in conventional cruise control, but it is cheaper, correct? That's what they initially implemented. First 30, 40 years. That's why in highway, particular speed, all the things. Still, you have to be very careful. In highway also, you have to be vigilant. 80 kilometers going, suddenly that fellow apply brake over. Right? If vehicle is not inter-vehicle failure, your vehicle definitely go. Even if you want to take manual control, take some time. If you are not alert, definitely go into your vehicle. So cruise control, you should not say 100 kilometers and all. Correct? 50, 60, 70, that is a safe distance. There will be some reaction type. You can take over control all those things. 100 kilometers and all, your vehicle, inter-vehicle space is only some 20, 50 meters. By the time you take control, correct? It may give warning, all those things releases. By the time, you have to be very careful. Right? Unless you are a very expert, like a Formula 1 race driver, 100 kilometers taking control is not easy. If you are not watching carefully. So these are the note on these points because again repeating, you are going to write exam grading. Understanding subject is one thing. I am very happy. In exam also, I want all of you get S grade, 100 out of 100. That means you have to write all the important what I'm telling also. Not only what I when you have key important point, you have to write, elaborate. Just not right. See, for example, tomorrow I ask about adaptive cruise code. Draw these two figures. I write the 4 points. You won't get 5 out of 5. Right? I'm explaining. You have to write sentences. Right? You know that that's how we do. We are doing for us now. Students think that what our slide shown that is sufficient. Nobody takes notes. Okay. Now, cruise control. I want to know. Before going to adaptive cruise, we want to know how to design the controller. Adaptive control, cruise controller. I told you it is a closed loop controller, right? It is a closed loop control system because there's a feedback. This is called feedback signal. Feedback signal, what it measures using wheel speed sensor. We are measuring vehicle speed. Set speed is compared with the vehicle speed and the error. You can see that error. Set speed is 70 kilometers. Current vehicle speed varies. Correct? It may go 30, 40 depending grade. Correct? It may go to 40 to 80. Accordingly, error will be this minus this error. The error signal will be amplified and appropriate control signal will be given to vehicle throttle control. This throttle will be controlled so that the vehicle speed is maintained. Right? This controller can be different type of controller. Any of you know about the controller? Proportional control, integral control, derivative control, PID controller, all those things. You have done a control course, you would have electrical students somewhere done. If you are mechanical, there are chances are very less. Okay. Don't worry. When we talk about mechatronic system, I will explain that. Correct? Mechatronic, there I teach about closed loop control for 5 to 6 hours. Proportional. Although without that, no present, no control. Without control, no system. Car, bike, motorcycle, engine, or brake, or rocket, aircraft, boat, robo, all are electronic control. You should know minimum of electronic closed loop control. That's why in mechatronic course, when I teach, I will teach that. Generally, in mechatronics, we teach about sensors, we teach about this one, control system, we teach about designing controller, right? Actuator, different actuator, electric motor, right? Hydraulic motor, how they are working, all type of sensor we will see. Fine. Okay, now if I wanted to design a closed loop controller, there are simplest controller called proportional controller. Also called P controller. Next one is called integral controller or I controller. The first letter, the I controller. Then third one is called derivative controller. Also called D controller. Right? These three are generally the proportional control can be used independently. Integral control, I control cannot be used separately. I will tell you how it is. So you will see P controller. If you see any of the control system, your car or vehicle engine control, if they talk of P controller, or they call PI controller. That means proportional plus integral control. Together they use combined controller. It is called PI controller. Otherwise, you will see PD controller, proportional plus derivative plus this. They call PD controller or PID. All three, proportional plus integral plus derivative. Together they form controller. I told you this controller can be any one of this. It can be just a proportional controller, or it can be proportional to integral controller, proportional to derivative controller, or proportional integral derivative PID control. It can be any one of the combination. You will not see I control separately like proportional controller or D control separately. There are some reasons that we will talk about when we talk about mechatronics. Right now, just keep it in mind. You will in your control, engine control, ABS, correct? ABS is a closed loop, correct? You are measuring wheel speed, where wheel is get locked. Accordingly, you modulate, pulse width modulation. We saw that, correct? Modulation, we said braking force, applying for some time, all this thing. There closed loop control. There you may use proportional to integral PI controller or PD controller or PID controller. Each one has some advantage disadvantages. Why this one? Sometimes they use only proportional. Proportional control is simple to implement. It is very simple to implement and cost effective. Cost is less. As I go for PI control, there are two controllers. That means it is little more complex, costlier. Compared to proportional control, it is costlier. PD control also, you have two controllers. So you see that as the controller combination increases, implementing the controller is little cost complex and cost also increases. PID control is best. Each one has a, but if I combine these two things, it has some advantage. P controller has some advantages in the world, in the universe. No system is perfectly good, perfectly bad. Or you cannot say this person is 10% correct or good, 10% bad person. There's a combination that applies to anything in the universe. Car, bike, you cannot say this car is the best car in the universe or world. Nothing like that. There will be a lot of disadvantage. Even if you have 10 crores, there will be some disadvantage. It may not give mileage, all this, but it may give acceleration. Well, all these things will be there. Powerful, smooth driving, but may cannot give mileage. Other car will give good mileage, it may not accelerate. Correct? Like this, there are chances of many chances are there. Now, it can be combination of this. So I will just take another 5 minutes to complete this. Please take down these equations also. Correct? So now, when you want to design the controller, correct? My controller is nothing but I have the vehicle. This is called vehicle model. When design the controller, I can develop mathematical model vehicle and design the controller without building the actual system. Controller physically you need electronic CPU, memory, programs, electronic circuit, correct? And the sensors and actual vehicle and put that all those things. That is called physical modeling. Inside that we say virtual modeling or simulation. Simulation means I can model my vehicle, correct? As a mathematical equation. Then this is a vehicle model. I want to what is the output? Vehicle speed. So this is a mathematical equation. Vehicle model means I'm saying mathematical model, correct? Mathematical equation which represents vehicle. How the vehicle can be done? In case of simplified model, I am talking about simplified model of a vehicle for cruise controller development. The vehicle model is nothing but very simple. Okay, so mass F, correct? So this is nothing but driving force, FD. In this case, FD is called driving force. M is the vehicle mass, correct? V dash, correct? V dash means acceleration. We know that F equal to ma. Newton's equation. Mass of any object is acceleration equal to the force. Left side, correct? So FD is the driving force, correct? If I giving this is input, who is generating FD? The vehicle? Engine, correct? Engine developed. Because the engine developed by controlling your throttle. By controlling your throttle, the engine developed a torque. Due to this, already we saw yesterday. The vehicle move, this is what is this? Tractional force. correct? Traction force on the tire, which moves the vehicle forward. That is generated by engine. Already we talked about engine power is given, correct? I told you can get a problem also when we talk to ABS, correct? How to calculate the traction forces, friction, all this thing already yesterday we saw in ABS. So this force is the input for the model, correct? This is, you can calculate depending upon the equation already yesterday. Please note down the equation. For this also, you may expect to calculate this also in the exam, correct? FD, if I given the engine power, correct? Engine speed, correct? Engine speed N, correct? 60,000 into N, we already formula is there, correct? Tire radius, all this thing you can calculate what is the driving force. Forward, the driving force FD. Now, FD is the input to the vehicle model. This is cruise controller model. Now, mass of the vehicle, total mass of the vehicle, M, multiplied by A, that is V dash, correct? This is, what is this? This force is nothing but which opposes forward motion. This is called inertial force. Inertial force of the vehicle. Inertial force opposes the driving force. Driving one force wanted to move, correct? This force opposes. Then what is other force is the opposing force? Drag force. Already we saw F. Aerodynamic drag force. Already equation is given yesterday. Please note down. In the exam, quiz or end sum, you can expect problems. Please note down what the equation. FA, aerodynamic. We know the CD, correct? I also said velocity V square, correct? And the formula is there, correct? Note down that. So from that you can calculate. Then FR. What is the FR?
Frictional resistance.
Rolling resistance of the tire. Frictional resistance of tire. We say yesterday say FT. Yesterday when we talk ABS, FT same thing only, here FR. Both are same. Remember, FT and FR same. Correct? So those equations you have to remember. Now this can be simplified. FD equal to this, which can be further, this portion can be simplified as F into M into V plus B into V. Correct? So you can see that this is also for aerodynamic drag. This is tire frictional, this one. And for when the speed is within very small range, correct? This can be simple. They call simplified model of the cruise controller. The B is nothing but combine this. You combine these two things and it gives some value B. Then it is proportional to V. If V changes, you can see that automatically the opposing force it changes. Now we can write this equation simply further, Jason. FD equal to, correct? This is in the time domain equation. In control system, correct? We'll say that everything. We'll say that for example, V of T. What is V? Velocity, correct? T, correct? T means the velocity of vehicle varies with respect to time. Correct? It can remain constant or it can vary also. If it varies, we call it acceleration. Otherwise, we call it so. For example, mass of the object within bracket T. That means you take a rocket. For example, rocket is launched on the launch pad. Correct? What is the weight? 100 ton initially. As the fuel is burned, as the rocket start moving up, the vehicle weight. This is weight. Correct? Is 100 ton. 1 lakh kg. As the fuel is burned, the weight start becoming 90, 80. When it goes to some 400 kilo, 500 kilometer, only the satellite will be there. Maybe 5 ton, 10 ton. Rocket will be this one. Correct? So the mass also is varying with respect to time. In case of rocket, but in the car it is not changing. This mass is fixed. Correct? Car weight never reduces. But no. What we are saying is we write general equation here. Ft of t equal to m into d by dt. You can see the d by dt. This t represent with respect to time. We are doing derivative with d by dt means with respect to time. We are taking the derivative of the velocity, nothing but acceleration. V is the variable. Correct? So this is we wrote in time domain. Now many times when you write, this is mathematical model. This is the mathematical model of cruise control. correct? This is called, please note, is simplified model. It is in time domain. Now, what we want to do is, we wanted to convert, so this is differential equation, correct? All of us studied the equation, correct? First, this is the first order differential equation, correct? D by dt is there. Now, if we have d square by dt into v of t, we say that plus d by dt of v of t plus something equal to fd. Then we say that this is a second order differential equation, correct? If you have d cube by dt cube something, you say third order. You know that solving the differential equation always difficult, time consuming and complex compared to solving, for example, a equal to mx plus b. This is called as algebraic equation. Sorry, I'll just take 2 minutes and stop, correct? They call algebraic equation, correct? What is algebraic equation? It is a mathematical equation. In algebraic equation, if we say it should have only plus, minus, multiplication and division. If only this has this kind of mathematical operation, that equation is called algebraic equation. Easy to solve by human, also by computer. Even your computer, to add two number a plus b, for example 5 plus 6, you give it to a computer, it may do it in 1 microsecond. Instead of that, you say 5 multiplied with 6, you write a C program, right? It will take 10 microseconds. This is multiplication. Similarly, 5 divided by 6, division, it may take even 15 microseconds, correct? So 5 minus 6, subtraction, it may take 2 microseconds, 1 microsecond, correct? But all these equations are faster to update. Instead of that, for example, your equation, d by dt of x plus integral vt equal to fd. This is called integral differential equation, right? Your system. So it has a differential function and also integration. Integration, it is not a single. If you want to do in computer, what do you do? What is integration? I have a curve t equals 0 to 100 seconds. I wanted to find the area under this curve. How will you do?
So basically, we'll convert into many parts, and every parts can be taken as a rectangle.
You divide into small parts, square.
Can be added.
Correct? You think that is a small rectangular. Correct? Width into height, multiply. Plus, you divide into 100 small parts. Correct? Use a Newton-Raphson method. Correct? Many methods are there. Finding the area under curve is nothing but integration. Correct? With 0 to 10 seconds, the area finding is nothing but integration. So that means you will integrate small strips. Correct? Find the width and multiply, add. Correct? A plus B. Correct? A into B plus A1, B1. This one, like that you add. So you will see that integration is a very complex operation. It will take more time. Correct? So solving an integral differential equation complex in computer also. Best thing will be, what you do is converting the integral differential equation into algebraic equation can be done using what we call Laplace transform. You would have studied in maths, definitely engineering, you would have studied Laplace Fourier transform in mathematics. Third semester, fourth semester, because I studied in fourth semester, third semester, studied in my BTech, and I did BTech. First year, different integral, all this thing. Third semester, you have Fourier transform, Laplace transform. Control system, compulsory, you would have studied Laplace. Correct? This is nothing but control system. So, using Laplace system, this is called time domain equation. Time domain equation is a first order differential equation. This is converted to algebraic equation using Laplace transform. How do you know it is Laplace? The equation is Laplace. Instead of using, you say the d by dt, you can see the s within the bracket, s is there. Correct? Vs. Correct? This fds. Correct? Vs, gs. Within the bracket, small s is, means that is, s is called a Laplace variable. It is called as Laplace variable. That means the equation is Laplace domain. Equation is Laplace domain. If I take a time domain equation, a differential equation, or even fd equal to m into a, this is already algebraic equation. This also can be converted to Laplace equation. A is varying with respect to actually AT. This FD of t equal to m into AT. Correct? Why? FD is varying with respect to variation A. If acceleration, mass is fixed for a vehicle, acceleration can vary from 0 to 100, something. Correct? If A is varying, FD will vary because it is multiplied. So these two are variables. These are called as variables, varying with respect to time. Mass is a constant. Vehicle mass doesn't change except rocket. Rocket mass itself is varying. Correct? They are called time varying system. This is called as time invariant system. Car mass is not varying, so it is called time invariant. But if the acceleration varies means if the force FD will vary. So this equation, if we convert to Laplace, it will become algebraic equation. See that this differential equation is now converted. Do you see any differential term? No. This differential term is converted to S term. Correct? You do that. Now, the time domain equation convert to S domain, which is algebraic. Then you find that this is called transfer function. G of S is called transfer function. Correct? Transfer function is nothing but output divided by input. What is the output in case of here? I wanted to maintain the velocity, vehicle speed, V. Correct? This is the vehicle speed, output of vehicle. What is the input? The force generated by the engine, FD. Output divided by input is transfer function. Already you have here. Correct? So from this equation, I can write this transfer function. This is called transfer function. I stop here. Monday, we'll continue cruise control, adaptive cruise control. Okay. Thank you. See you on Monday.
Thank you, sir.
Thank you, sir.
Thank you, sir. Have a nice.
Take care. Have a nice weekend. See
Thank you, sir.
Thank you, sir.
Give your attendance as a chat message.
Thank
Sure,
you, sir.
sir.
Thank you so much.
Okay.
இப்போ அந்த அக்ரிமெண்ட் சைன் பண்ணணும் நீங்க அந்த
Your
அக்ரிமெண்ட்
attendance for you only, not for your friends. I see only less students, but more chat message. Don't give it for your friends.
No, actually, what happens, sir? Sometimes we get thrown out of the meeting. So once we join again,
But same name can appear. But